All right, it is our last set of notes for the semester. And we have learned 5 different ways to prove triangles congruent. Now remember, when two triangles are congruent, all their corresponding parts are congruent. And so that's what we're going to be learning about here. Okay, I guess, I thought I put it down. Oh, well. So CPCTC stands for corresponding parts of congruent triangles are congruent. So that's the CPCTC. So when you have two triangles that are congruent, and that's what we've been working on, right? Proving triangles congruent. Then once you have the triangles are congruent, you can talk about other parts of the triangle being congruent, parts of those corresponding parts of those triangles. So we want to show, let's say we wanted to show angle A congruent to angle C. Well, in this picture, let's just talk through it. Do you see how that would be a third side? So we could prove, and now is where we're going to have to be really careful about how we name things, because we are not given the congruent statement for triangles, but we're going to have to do it. So it says explain. Let's just put it kind of down. BD is congruent to BD by reflexive. And then that makes triangle BAD congruent to triangle BCD. Remember, we got to make all the corresponding parts match by side, side, side. And then now, since those triangles are congruent, we can say angle A is congruent to angle C, and then our reason is CPCTC. Because, once two triangles are congruent, then all their corresponding parts are congruent. So what's those two triangles are congruent? Angle A corresponds with angle C, and those would be congruent then. All right, so now all of our proofs now are going to involve CPCTC. That is, we're going to need to prove the triangles are congruent first, then we can talk about the corresponding parts. So we've got angle MNP congruent to angle OPN, and we have MN congruent to OP. Okay, so, and everything's marked. Great. Now, we want to prove this and this are congruent. So to do that, we need to prove those triangles are congruent. So number 2, let's talk about this common side there. Let's say NP congruent to NP, reflexive. And now we have enough. We have side, angle, side, see? So we can say, and this is where we got to be careful, triangle MNP congruent to triangle OPN. This must be done correctly. And that's by side, angle, side. Oops. And now we can say side MP is congruent to side NO by CPCTC. Corresponding parts of congruent triangles are congruent. All right, next one. And if you're watching the video, which obviously you are, if you want to pause it and try these on your own first, go right ahead. Oh, great. Well, let's see. They give us ST congruent to VU. You know what I'm also going to write down is given? Angle S and angle U are right angles. Because see, do you see that in the diagram? I'm just going to say it now as part of the given. All right, so I'm going to talk about this, right? Let's say TV congruent to TV. reflexive. And so we have right angles. There is no ASS, right? That's not one. But what this is with the right angles, we do have hypotenuse leg. This is the hypotenuse. This is a leg. Here's our right angle. So we can say, we gotta say these correctly. Let's say TSU congruent to triangle. Oh, I'm sorry, that's TSV. V congruent to triangle TSV. VUT by hypotenuse leg. And then now we can say SVT. And you know what? We could always use this to help us write our congruent statement. So SVT, UTV, yep, we did it right. That those are congruent. So angle SVT is congruent to angle UTV by CPCTC. And finally, oh, let's try that again. Finally, we have AB parallel to DE, and C is the midpoint of AE, given. Okay, so we see the parallels, all that. So C is the midpoint of AE. So here's AE, right? If C is the midpoint, then that would make AC congruent to EC. And that's because a midpoint divides a segment in half. Okay, so we do have that. But now our parallel lines. So let's, maybe I'll use my highlighter. So we've got these lines parallel. Let's look at one transversal. So can you see these would be, here I'll mark them with the pen. These would be alternate interior angles. So I can say angle B congruent to angle D, and that means parallel lines, alternate interior angles congruent. Now, let's take out that one. Let's put in the other transversal. And that would mean that these angles are alternate interior angles. So we can also say angle A is congruent to angle E for the same reason. For the same reason. And so now, notice we have angle, angle, side. Angle, angle, side. So now we can say triangle ABC congruent to triangle EDC by angle, angle, side. And now finally we can say BC congruent to DC by CPCTC. And that's our last one. So you can see, very similar to what we've been doing. It's just our proofs are going to have one more step by talking about a corresponding part of those two triangles.